Okay. So today's date is recording. That's fine. All is not good. Mm. Okay. Okay. Um, today's date is 30th of June, 2026. This is a great deviation of what I normally do, but it has been done. What do I mean? Okay, so here I've got the five observables. Let me close this down. The five observables.com. Archive of leaked official unidentified error phenomenon footage. A UAP was encountered, was tracked on multiple sensors, behaved in ways that surpass understanding and technology. Retro fighter pilots Ryan Gravis. We are not taking any prosaic origin identity. Former intelligence officer turned whistleblower, David Birch. I have never seen anything in my life in the history of flying that was high performance. The solution, keep in mind, these things has no wings. Retro Commander, wait, Return Commander is a title. Return Commander David Flower, you know. The science footage and recordings in the skies that have not done exactly what they are. Former US President Barack Obama, a retired retired commander. Okay, let me get. They jumped from spot to spot and tumbled into a way that was unpredictable. Okay, so the five observables.com is literally about things observed and we can't really translate it on from it. I don't remember how to say it properly. So let me choose raw website, because it's a UAP, an unidentified error phenomenon, which I know is as a five, which I classify as the five observables. Yes, that was it. So the five observables are classified as UAPs. I'm trying to build basically. I'm gonna be clear what I'm trying to do in this video. In this video, I'm gonna try to introduce my own written explanation of the five observables. But that means I have to go through the five observables itself. The unidentified error phenomenon. Is it UAP? Is that what it stands for? Let me just say UAP definite meaning. Oh, unidentified anomalous phenomena. UFO, unidentified flying object. Unidentified anomalous phenomena. Basically, it's UFA. This is more accurate than UFO, UAPs. But this you the file.com. So, by the video here, you got positive left, positive left. Left is negative. Yeah, left is negative. Anything. Basically, I wrote a lot of AI using format some ideas into ontological based intelligence documents. All the documents I put there, I've put them onto my GitHub repo. And one problem here is I call it the proportion, the proportion pollution problem. The proportion pollution problem. This applies to all classes of the just like to explain what is going on to myself. Okay. Okay. I'm not saying our science is not wrong. Our science is not wrong. Our math is not wrong. I understand it's not wrong, but we are building wrong. We are building wrongly, like in a wrong way, like in a way that doesn't really. That's what the problem. What I mean by that is that um, we have proportion. I have pollution. The proportion pollution problem. Proportion pollution a hypothesis. It's in a system we are proportion is like having a lift, just if you need the proportion to having to get a lift, you need a difference in thrust. If I remember, because I'm a scientist, I remember when I did applied physics creative writing. So applied math and creative writing. Basically, to create lift, you must have more aerodynamic under the craft, like in the helicopter flies up, but those are negative lift. So, you must generate force that is unequal on two ends, because, the helicopter has a top, like, above the helicopter and below the helicopter, from the helicopter point, some of you. But, you have to, put, this is called negative lift. But positive lift uses positive because it's my understanding is negative lift. Hopefully, I'm getting this right. Because negative lift is like you system loses a bit of thermodynamic principles. Thermodynamic principles. But what we're seeing is that these things don't don't obey. They don't follow the conventional thermodynamic principles. Because positively is not a, it's not even a okay. Because what are the laws of thermodynamics? Laws of thermodynamics. Let me just find it here. Did I pin this tab? Uh, Laws of thermodynamics. Because I don't want to be wrong, so I have to research it while I go along. Laws of thermodynamics. So again, I have three main laws. Um, Four fundamental principles how governing heat and energy work within physical system. These are called the laws of thermodynamics. Zeroth law, zero law. Thermodynamics studies energy and transformation relationship. Heat. This is basically. What's the first law? A fundamental law. The first law is expressed. Wait, is it? Why is look at the email? Okay, this is a good example of it. Define temperature equally. If two bodies are within a third, it's in an equilibrium. Equilibrium law, zeroth law. First law, energy remains constant if transformed current is shown. Energy is constant in a system. Second law, entropy is isolated in a system. Heat flows from hot to cold. Um, and this is open closed system. Like, energy can come into the system. And third law, the four laws of the four laws. Just note, zero law. So these are fundamental principles of thermodynamics. And for me to explain this, I have to remember my thermodynamics courses are done. Entropy allows a constant value as temperature approaches zero. So this just means these apply in all circumstances of law because energy cannot be created or destroyed. Third law, entropy approaches a constant value as a temperature approaches zero. Basically, entropy distribution. Entropy distribution is basically energy from one end of the system if the system is not compact. Like if there's space for the system, if there's a volume in the system, if there's more volume it has, the more less entropy you have because energy moves from high entropy to low entropy to high entropy. I mean, no, high entropy, low entropy to high entropy. Because that's talking up. So, I don't want to be wrong here. Thermal equilibrium, first law, conservation energy, second law, entropy, and absolute zero. Yeah, yeah. So these are the four laws of thermodynamics. Let me just pin this page. Britannia. Let me put Britannia. So the thing I'm saying is that bookmark tuber, a bigger bookmark menu, Mozilla. These laws apply, and my hypothesis is not a problem. The problem, if you can frame it as a problem. So the problem, my framing is that the proportion pollution, the more proportion you have in the system, the more pollution that system has. But these things, all these things that travel, that have transmission travel, low observability, hypersonic velocities, instantaneous acceleration, and positive have zero proportion. They have zero proportion. They have zero pollution. They have zero pollution, but they maintain proportion. So my understanding is our technology is we're building inefficiently. Or not wrong, sorry, I said we're building wrong. We're building inefficiently. The math is there, but I said wrong before. We're building inefficiently because we're building stuff. If I had my 3D printer working, like I said, a 3D printer to print my workout, if I'm a 3D printer right now, things we're building are inefficiently because because a framework of work done in a system, work done is like mm, it's like I hope I'm making sense right right now because work done is let me just go to give for gifts to remember work done. Work is the amount of system work done in system is the efficiency of a system, which is calculated by work the amount of work is done. So efficiency equals work done, which is which is to convert systems like uh 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 system energy systems, between like air resistance or drag, or like energy between energy in mechanical systems which are physics bound. So I can't remember how to do it, but there's a way. It's not a trick of mine. It's done in standard physics, standard thermodynamics, or standard science. You take an energy, you take a energy in joules, uh, energy in joules, and you take that energy in joules and you convert it, and you and you put it in some kind of system, some kind of thermodynamic system, which is what the foundation of classical physics is. Classical mechanics, also known as engineering. Uh, Classical mechanics or engineering. And then you compute the work done at which give you the efficiency. Physics dot no basically just go mymaths.com. Mymaths dot work done. My work done. How to calculate work done. How to calculate work. I'm just gonna do it. How to calculate work done. Work was force times displacement. You know, very simple stuff. Just key system. Work done equation. Yeah. And work is done is measured in joules. Force is measured in newtons. Distance is measured. Work is measured in joules. Yeah. Energy, which is joules. Yeah, I was right. I remember this properly. Okay. Power. Power equals work done divided by time taken. This is what I'm saying. Uh, 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 watts. Power is measured in watts. So The idea of me talking about this is to I'm not thinking granulars. This has to be a long project, like like my ontological Bayesian intelligence framework. It will be a long exploration of the hypothesis. This is my repo, by the way, and to actually build it on the rule to see whether I'm right. But this is the OBI repository, ontological Bayesian intelligence. This is my own work. This my own dimensional game theory for AI. This is my own work on. This is basically a lot of pseudocode, but it's a gold mine for ontological Bayesian intelligence. So this is a different framework here, but the proportion pollution problem is that we're not building efficiently to ensure that the work done in the system and the energy work is measured in uh, force times distance or displacement based on the quantity you are using. But this is a positive lift. So for example, this is positive lift. How can something take positive lift? Use positive energy to generate lift because positive energy are protons, and everything works on electrons. So electronic lift, electrons are positive. So I'm not sure what the definition of this positive lift is. Oh, positive lift, possible observation, positive lift. You see, it just goes forward. And this is just one video, September 2019. So this have to go research. It's called research R&D. See, this is positive lift. This is how it's flying and it's going through the map of the United States. Wow, it's going so fast. So these things are literally some of the worst things that could happen. Not the worst. These are threats to national security. U.S. hellfire, missile bouncing off a show. So my understanding is you got take two magnets, two magnets are poles, positive and negative charge. They normally equals to their positive charge, so they're attract. But to have positive energy, you have to have two opposing systems, two negative systems, so you create that can be collaborated to have positive charge. And that produces a great positive lift. So that means there's no proportion because it's all electromagnetic. It can be induced. It can be turned on electrically, and magnetically it just goes up. So these are the things I should be really investigating because I'm 24, I'm 25 right now, and I personally I should be building stuff my own. I just don't have the money to build it. Like robot parts. So these are robots I want to build, ontological Bayesian intelligence here. But this is a good key part of my engineering. So it's part of my science, technology, engineering, math. So power is measured in watts. Yeah, power is measured in watts. Work is measured in joules. Distance is measured in force. The displacement is measured in time. Displacement distance is measured in. Oh, this is not measured in force. Power or momentum. So for me personally, I'm trying to build robots, and there's no support for me. So force and distance, force measured distance measured in meters, and work is you should never forget. But I couldn't work it out with the kind of sheets by my side, the work done. So these are the examples I'm giving here. Yeah, it's not scary. It's traveling. It's not good as fast as traveling. Instantaneous security. Instantaneous security. So this is instantaneous realization. This is an example of the five observables. because I'm not going to study this properly. So my whole life work should be on the five of those. Both as I'm building ontological based intelligence and MooCOS, and but I have to focus on something. I am just to work in the human rights framework of OB Nexus, which is very important. For new individual people, I'm gonna be working a lot of things. But the idea is to start debunking some of this stuff and start working, demystifying them too. So the hypersonic missiles velocities are hypersonic. So sonic hypersonic means as hypersonic at the speed of sound, five times the speed of sound. A craft ability to travel five times the speed of sound without emitting sonic without emitting a sonic boom. That is scary. That is a start, because that means there's energy in that system, because there's energy in that system. So, for me, I'm gonna dedicate my life to five observables to build it properly, to build activity properly. I'm gonna dedicate myself to Insigi, Muko OS, OS, the digital one. Rift is a flexible translator. Nlink and Lipolical, as long as I'm happy with them production. So, these are the kind of framework I'm proposing, because, we are building something that is gonna be going fast and going safely fast, you know. So this is not a matter of opinion, it's a matter of safety and how they are a threat to national security, UK or Nigeria or because they are not the airspaces. Airspaces which we govern. Low observability. This is low observability, the jellyfish UAP. So just going because I want to build around. This is a military base. So this was 2018. Someone's calling me, guys. Thank you for watching this video. Thank you for watching. I'm being called.